All right. Welcome back, everyone. Good morning. Math 161. This is, what is this, week 3, lecture 2. So today we are going to continue with 1.5. I say continue, but honestly, I really mean start, because last time the stuff we did from 1.5 was really just review of old material. We didn't technically start anything from 1.5, but it was relative to 1.5. So last time we finished 1.4 and we assigned that homework, and since we finished that on the 25th, we said it was due on the 1st. We are going to get close to finishing 1.5 today, but we will not finish it unless I go unless I go a lot faster than I'm anticipating. I'm expecting to have about 10 to 15 minutes left next time. And just as an FYI, this will be our last Zoom meeting together. The administration has decided that we are allowed to go back in person starting on Tuesday the 1st. So again, this will be our last Zoom meeting. You will actually have to wake up and get ready and shower and all that good stuff and go to TCC on Tuesday the 1st for our 8 a.m. class, bright and early. So make sure you set your alarm clocks for like 30 minutes earlier than normal, probably. I don't know about y'all, but I'm pretty excited. If you're not, I'm sorry, that's the way this class is going to be run. I've been waiting for this to go back to in-person, and there's always the possibility that cases rise and we'll have to go back to Zoom, but I don't know. I hear some people saying, oh, the cases are exploding again. That's not the trend I'm seeing. I'm seeing a downward trend, but maybe we're looking at different data. I think that explosion is on its way out, but we'll see what happens. So again, we are going to be back in person starting next class, which means classes will no longer be recorded and put onto YouTube. I'm not going to record classes in person. It's a lot more complicated. It's a lot more time involved. And it's already more time involved to be in person, which again, I prefer, but I can't double up, especially teaching 21 credits. So that would be the case for both the Math 161, as well as if you were in my MDE 61 at, what's that, 11 o'clock. All right, so last time we talked about all the different types of factoring. We're not going to go over any of that again. You just need to be prepared to do that stuff today. So 1.5, quadratic equations. We're going to go over the 3 primary methods of solving quadratic equations. The first being solve by factoring, which we've already talked how to factor. The quadratic formula, which some people might already remember, that negative b plus or minus blah, 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 blah thing. And then completing the square, which most people forget if they learned it before now. Most people admittedly don't like it until they've used it 20 or 30 times. But it is actually a really awesome method. It's awesome for things besides just solving quadratic equations. And it's also where the quadratic formula came from. And if we had more time together, I would show you that proof, but we don't, so I won't. So these are the primary methods for solving quadratic equations, which are of the form ax squared plus bx plus c, where a, b, and c are numbers. Come on. My computer is really running slow today. So a, b, and c are numbers. So something like x squared plus 5x plus 6 equals 0, or 2x squared minus 7x plus 11 equals 0, or 1/2 x squared plus 0.02x minus 3/9 equals 0. They can be fractions, they can be decimals, they can be reduced fractions, they can be non-reduced fractions. They can even be rational and irrational numbers, but for the sake of our sanity, we'll leave irrational a, b, and c out of the case because that would be a headache. So the first and arguably easiest method, as long as you have factoring down, is to solve these by factoring. Now, what's key is that everything is all on one side. You've got everybody in one room and then nothing in the other room. So that's if you want to solve by factoring. So the first step to solve by factoring is move everything to one side so that the other side is 0. It doesn't matter if everything's on the left side or the right side. You can move it however you like. Me personally, what I would do, and maybe write this down even though I don't have it written down, I like the leading term to be positive. I never like my leading term to be negative because it makes factoring much more complicated, and it even makes the quadratic formula more complicated. So I always like my leading term positive, so I'd move everything to a side to make sure that that was positive. Then you factor. So the second step is factor, one word instruction, and man, is that a loaded instruction, because maybe it's a difference of squares. Maybe it's a shortcut method. Maybe it's an AC method. Maybe it's something else. So that one word has got a whole universe inside of it. Maybe it's just a GCF. Who knows? Then what you do is you use something called the zero product rule. Now, the zero product rule says that if you have two things being multiplied and you don't know what either of those things are, so some A times B. I got A times B, but I'm told that A times B is 0. The only way that could ever happen is if either A is 0 or B is 0. If you have two unknowns being multiplied, but we do know that the product is 0. Only way that works is if one of those values is 0. Just think about it. What number can you multiply anything by to make it 0? Well, 0. Well, when you factor things that have variables in them, that means they're unknowns. So you'll have two or more unknowns multiplying where you don't know what they are because they're unknown, and they're set equal to 0, which means one of them has to be 0. Well, the thing about unknowns is they can actually be 0 at different moments in time. So the first thing could be 0 when x is 3, and the second thing could be 0 when x is 4. So what you do is you just find out when, when in time, in other words, for what values of x, when that happens, so you set each factor equal to 0. You get to create multiple equations, and they will be much simpler than what you started out with. That's what our zero product rule is. It says if you have a product set equal to 0, and that product involves variables, just set each of the factors equal to 0 to find your multiple solutions. So you're going to find that there's 2 or 3 or 4 or 5 solutions to these things. Now, admittedly, for quadratics, there can only be at most 2 solutions. But there are also equations of higher order that you can solve by factoring, and there could be 3 solutions if it was cubic, or 4 solutions if it was quartic, or 5 solutions if it was quintic, which means it had an x to the third, or an x to the fourth, or an x to the fifth. All right, big ugly rant aside. What's the process to solve by factoring in as little words as possible? Move everything to one side. Factor, set each factor equal to 0. Boom. If you're rusty with factoring, you're going to have a bad time here. So go do 100 factoring problems and come back. Okay, so example 1 we're going to solve. Let's go with, I'm going to zoom in just a little bit. And I also want to change my color back to black. X squared plus 8x equals negative 15. Again, x squared plus 8x equals negative 15. So how do I know this is quadratic, or how do I know that I might be able to solve this by factoring? Because there's a higher exponent. If there was no x squared term, if this was just x plus 8x equals negative 15, you'd combine like terms, move the variables to one side, divide, et cetera, like we did in a previous class. The x squared changes the game. So we want everything to one side. You could move the x squared and the 8x to the right, but trust me, that's a bad idea because then your x squared is going to be negative. Let's move the 15 to the left, and I got to kind of squeeze this in like so, because I don't want to put it directly under the 8x. I might accidentally combine like terms. What you could do is leave a little space here in another line. That's up to you. But what we'll get is x squared plus 8x plus 15 equals 0. Almost lost my pen there. Then step 2, factor. This is a 1, 2, 3 term trinomial. So it's trinomial because it's 3 terms. There is no leading coefficient written, which means it's a 1, so we can use the shortcut method. This is where we go to the side and we write the 15, the plus 15. We list all the factors pairs of 15, which are 1 times 15. or 3 times 5. Now, this is if you're following my methods. If you factor another way, be my guest, do it however you do it. We're trying to find which of these pairs adds to make the 8. 1 plus 15 is 16. 3 plus 5 is 8. So that's our choice. But we can't just say it's 3 and 5. We have to give them appropriate signs. They're going to have to both be the same sign to make sure they multiply to a positive. And to make sure they add to a positive, they'll both have to be positive. If this was a negative 8x, they'd both be negative. If this had been a negative 15, they'd need to be opposite signs, and this actually wouldn't work as a problem, but that's not the issue. So what we get is, in parentheses, x is in the first spots, and then a +3 and a +5 in the second spot, whatever the numbers and signs we chose were. But don't forget the equal 0. A lot of people will drop that. Don't forget the equal 0. That was part of your equation. This wasn't just a factor problem, it's an equation. And then we step 3, zero product rule, ZPR, set each factor equal to 0. So we set x plus 3 equal to 0 and x plus 5 equal to 0. This is 2 equations that we solve independently. And they're pretty easy to solve in general. Subtract 3 on both sides for the first one, and we'll get x equals -3. Subtract 5 on both sides for the second one, and we'll get x equals -5. Again, this is supposed to be something you've done before if you are taking your math classes in the appropriate order. But if not, you've got to practice on your own. Most of the stuff in chapter 1 is review. A lot of the stuff in chapter 2, in fact, is review. It's not till chapter 3 and 4 that everything is brand new. And there we are. And if you don't trust this, remember you can plug a solution into the original equation and see if it works. I'll try the -3. I'll let you try the -5 on your own. -3 when you square it is +9. 8 times -3 is -24. And guess what? 9 minus 24 is -15. It works. But for B, 2x squared plus 7x minus 4 equals 0. Now, these equations can come of all sorts of different types at the beginning. You might have some distributions to do. You might have some like terms to combine. You might have things to move. Or you might just have everything already set equal to 0. I'm just trying to get down to brass tacks because we have a lot of material to cover in this section with very little time. So 2x squared plus 7x minus 4 equals 0. Everything is already on one side. So I don't need to move anything. So I'm going to, since the leading coefficient is not a 1, I might say, well, is there a GCF? Well, no, there isn't. 2, 7, and 4, nothing goes into all those. So this is going to be the AC method, or trial and error if that's what you prefer. I didn't really talk about trial and error too much. But again, you factor however you factor, as long as you can factor correctly without using a calculator. So that's where we take the 2 times the -4, which is -8. And then we're going to do the same thing as over here in red. Write the multiples, 1 times 8 or 2 times 4. But this time, because it was a negative, we're going to subtract the pairs to make 7. 8 minus 1 is 7, 4 minus 2 is 2, up. 8 minus 1 is 7, so that's our choice. But we need to give this pair of number signs. They need to come out to a +7. If you went +1 and -8, that would make a -7. You need to go -1 and +8. You might say, well, why not both negative? Because that would add to -9. -1 plus -8 is -9. It would also multiply to +8. We're trying to make a -8. Now, you do not go straight to x minus 1 and x plus 8. That's the shortcut method. We are supposed to split the middle term up. So we go 2x squared minus 1x plus 8x minus 4 equals 0. So we split the middle term in 2 using the selected numbers to the side, hence why I did it in red. And then from here, we factor by grouping, which is 3 GCFs. GCF from the first pair, GCF from the second pair, then you should have a matching parentheses, and that's your third GCF. Again, if I'm going quick, it's too quick for you, you need to practice. All right, so the GCF from the first pair between 2x squared and 1x is going to be x. That's all you can take out, which will leave us 2x minus 1. 2x squared divided by x gave us the 2x. Then negative 1x divided by x is minus 1. It's not a blank. You don't leave this blank, because if you distributed it, you wouldn't get the original line. Between 8x and 4, now because this is a plus, the general rule of thumb is that's going to be a plus. 8x and 4, we can take out a 4 as a GCF. Open parentheses, 8x divided by 4 is 2x. Negative 4 divided by 4 is a negative 1. Don't forget your equals 0. Now, this guy has a 2x minus 1. This guy has a 2x minus 1, which means your third GCF is 2x minus 1 in parentheses. Then we open another parentheses, and whatever is left over is what goes in the second parentheses. So you just cover up, don't actually permanently erase these, but cover up the GCFs from above. I only see an x and a plus 4 left over, so that's what goes in the second parentheses. And there we are, we're factored. It is possible that that black ink could be factored more sometimes, but not in this case. Now we zero product rule. We set each factor equal to 0. So we set the 2x minus 1 equal to 0, and we set the x plus 4 equal to 0. These are independent equations. Don't try and cross-communicate them. I'm actually going to do the second one first because it's easier. Just subtract 4 on both sides, and we'll get x equals negative 4. Boom, done. That's one of them. The first equation is going to have 2 steps. We've got to add 1 to both sides first, which will give us 2x. Whoops, I thought I changed my color. No, I hit it. 2x equals 1. Then we got to divide both sides by 2, which will give us x equals 1/2, or 0.5 if you prefer decimals, since it's a nice clean decimal. Up to you. I prefer the 1/2 because there's no conversion necessary. So I could do 20, 30, 40 of these, and they could all have pretty significant differences in them. We just don't have that kind of time. Once again, it just relies on factoring. Practice the factoring on your own. I gave you some homework that you can try out from with factoring from 1.5. That would be a great practice set. I gave you a website with instructions and some examples you can go through there as well. And then there's other resources online that you can use. In my MDE class, we did a lot more rigorous instruction and practice of factoring that we're going to be continuing today. I'm thinking about making those couple of videos available to my 161 class. If anyone thinks they'd like to see those, shoot me an email and let me know, and I'll make them available. It wouldn't take me more than like 10 minutes. So I think that might be a good idea. If you like my way of factoring in my instruction, I gave you a slower breakdown and more examples. You can also just go to my YouTube channel, find the MDE 61 playlist, which is public, and there you go. All right, so that's how we solve by factoring. Now, there were 3 methods up there: solve by factoring, quadratic formula, and completing the square. But we've got to go over some intermediate stuff before we get to the other 2 things. The first being something called the square root property. And oh boy, let me tell you, this is something that no pre-calc student ever wants to memorize. I'm not going to say doesn't want to memorize, they just don't. They get this wrong. Every single student gets this wrong at some point. Some of them get it wrong once or twice and then have it forever. Some of them get it wrong 5,000 times and never want to remember this plus or minus feature. And if you miss that feature, you are only getting half the answer right. Now, some teachers say, well, you didn't get it right at all, you get no credit. Some teachers say, well, you got half the answers, so I'll give you half the credit. Some teachers will say, well, you did all the other work, you just missed one step, so maybe it's only going to be, like 10 or 20% of the credit off. I'm kind of between the second and third teacher. Depends on how long the problem is. But I'm definitely not the first teacher. So what is this square root property? If you have anything squared, and I mean anything squared, x squared, parentheses x minus 3, close parentheses, squared, and it's set equal to a number, 5, a 0, a negative 7, whatever, then that means the anything that's being squared is equal to the plus or minus square root of the number. Let me write this out in a non-sentence form. What I'm saying is if you have anything squared equal to a number, what this ultimately means is that the anything, when you unsquare it, is equal to plus or minus the square root of that number. And this is the feature that everybody misses. Oh, if I have x squared equals 9, x equals 3. Sure, x equals 3, but it's not the only solution, in fact. It can also be negative. So they go, oh, well, yeah, you just take the square root of both sides. But it's not just take the square root of both sides. It's take the plus or minus square root, but the plus or minus only goes on the side with the number. So in other words, again, i.e., take the plus or minus square root of both sides. But again, I'm just verbally saying the plus or minus only actually goes on one side. Why is this? Let's use our noggins. Let's think. If I had x squared equal to 25, what can x be? Without thinking of any of this stuff we just talked about, I know that most of my students are instantly going to go x equals 5. And that is correct that x equals 5. Since 5 squared is 25. But exclamation point, x can be negative 5 too. Because if you take negative 5 and you square it, it's also positive 25. Not 25 factorial, that's not what I'm using the exclamation mark there. If you don't know what I just said, then ignore it. 25 factorial would be a ridiculous number. Very, 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 very large number. We're not doing factorials in this course ever. That's a statistics thing. It's a cool thing, but it's statistics. So there's this inherent property. It's called a loss of sign generality. When you square a number, you don't know if the original number was positive or negative, because it's always, when you square it, it's always going to turn positive, right? Unless it was imaginary, and we're not worrying about imaginary numbers with this stuff. So if I said x squared is equal to 100, you don't know if the original number was 10 or negative 10, because when you square it, you lose that sign in general. Loss of sign generality. So we account for that. How? We account for that with the plus or minus. That says, all right, I don't know if the original thing inside was positive or if it was negative. In fact, it can be both, as long as there's no restriction on our variable, as long as nowhere it says x has to be positive. So we allow it to happen. We just say plus or minus, and then take the square root. Boom, done. But again, what happens with most pre-calc students? They forget the plus or minus. Honestly, what happens with a lot of calc students? They forget the plus or minus. And again, you've lost half the problem with that tiny little detail. Too far. Let me just bump this down because I want it to be on the screen. But not that. Example 2. Solve. X squared equals 16. Now, what some students are going to say is an alternative method that I'll show after this one. But let's do this the way we just introduced for now. But I will tell you, there is more than one way to skin this particular equation. You could solve this by factoring. You could solve this by using the square root property. You could solve it by the quadratic formula. You could solve it by completing the square, which would feel redundant. 4 different ways off the top of my head we can solve this. And honestly, that's not even all of them, but that's all we would do at this level. The easiest one is what's on screen. All right, if x squared equals 16, half you already know x equals 4. But you've missed half the point. It could actually be a -4 as well, because when you square -4, you get positive 16. So here's what you do. You take the plus or minus square root of both sides, but you only put the plus or minus on the side with the number. Because this x counts as anything being squared. This is our anything being squared. I can't have x squared plus 7x. That would not work. It has to be on one side, just something squared. Why do we do this? Because what do square roots and squares do? They cancel. This is like when you have a +5 and you subtract 5 on both sides. When you have a 3x, you divide by 3. This is an opposite operation. Square roots and squares cancel. But you can't just take the square root because of that loss of sign generality. You have to throw that plus or minus in. So this states that x can be 4 or x can be -4. Now in my math lab, you might have to write 4, -4. Just so you know, there might not be a plus or minus feature in there. What's the alternative method I just mentioned? Well, we just went over this method in example 1, solved by factoring. So x squared equals 16. You could subtract 16 on both sides. I'm not going to change colors. I want to get this done quick. So you get x squared minus 16 equals 0. This is a difference of squares, your a plus b times a minus b, where the b is 4 and the a is x. So we go x plus 4 times x minus 4 equals 0. 0 product rule this. So we set x plus 4 equal to 0 and x minus 4 equal to 0. Subtract 4 on both sides to get x equals -4. Add 4 to both sides to get x equals +4. The same 2 solutions, just handwritten slightly different. But again, what a lot of students will do is they'll eyeball x squared equals 16. They rush, they say, oh, x equals 4, I'm done. And then they get it wrong. And on the homework, they're not getting any credit for it. You'll have to do it again. On a test, you show your work, and maybe I give you half your credit. All right, so Mr. Beckner, why are you giving us so many different methods if that red version works? Why wouldn't I just solve it by factoring? Well, here's why, Johnny, or Jane, or whatever your name might be. What about problems like this bad boy? Now, someone might say, oh, we'll take the parentheses, multiply it by itself, FOIL, combine the 6, move the 2. It's all by factoring. Well, A, that's a lot more work up front than what we're about to do. B, this problem is actually prime if you did all of that. You cannot solve B by factoring. In fact, 98% of the problems, if I just wrote numbers randomly on the board, would be prime. Only like 1 or 2% of problems in the world are actually factorable. Now, in the world, we tend to see those factorable problems more frequently, especially when teachers get the problems. But you have to be prepared for any situation and strap in. All right, so this rule says if you have anything squared set equal to a number. Well, this right here is not anything squared. There is an anything squared, but this -6 is tagged along. So what I actually need to do is first move the 6, which will give us parentheses 2x plus 3 squared equals 8. Now that is not 4x squared plus 9. You would have to multiply that thing by itself and FOIL it. And again, that is not actually a good idea. You're going to hit a dead end for now. You actually would need the quadratic formula later if you're going to do that. This counts as anything being squared. We are under the umbrella of the square root property. So what we do here is we take the plus or minus square root of both sides. Well, we only put the plus or minus on the side with just a number. Why is it we do this? Because we have a square root of a square on the left side, and those cancel. We're just left with the inside, which is 2x plus 3 equals. Now this plus or minus square root of 8, let me go to the side. Square root of 8, you can't take, but we can write 8 as 4 times 2. It's an ugly looking 4. Do better than that. Because we know the square root of 4 is 2. So this square root of 4 is that 2 on the outside. I took the square root of 4, but I don't know the square root of 2. So this is what stays inside. So that plus or minus square root of 8 becomes plus or minus 2 square root of 2. And you do have to simplify that. If you leave it as square root of 8, unfortunately, my math lab's going to mark it wrong. It's partial credit on a test if you let me know about it. But on homework, you just have to fix your issues. Homework's like therapy, math therapy. All right, so this right-hand side, oh my Lord, that was weird. Oh my Lord, how am I supposed to handle this number and subtract 3 and divide by 2 with it? Well, you just write it, basically. You're not going to worry about the dirty details. I want you to pretend that that right-hand side, just imagine it's a 7. Just pretend in your head that's a 7. And you're focusing on getting rid of the 2 and the 3. What do? Well, you're going to have to subtract the 3, and then you're going to have to divide by the 2. So let's subtract the 3. But I want you to notice where I put this. I left a little space in front of the plus or minus, and that's something I want you to get used to. You do not want to put that under the square root. You do not want to put it under the plus or minus part. Make sure it goes in front, because it's not going to be combinable if there's a square root there. So we get 2x equals negative 3 plus or minus the 2 square root of 2. You actually can't do anything with that. If this square root of 2 wasn't here, you could split the cases and do negative 3 plus 2 and negative 3 minus 2. That happens sometimes, but this is a pretty frequent occasion. Now what we're going to do is we're focused on the 2 times x. Again, I don't care what this number on the right-hand side is. Pretend it's a 40. 2x equals 40. You would divide both sides by 2. So do the same thing. I prefer this as an all-at-once division. And that will give us our solution of x equals negative 3 plus or minus 2 square root of 2 all over 2. You cannot reduce this because the negative 3 doesn't have a factor of 2. If this was a negative 6, you could cancel a 2 everywhere except in the radical. We talked about that once already. You would have never come up with that solution by factoring, trust me. And if you could, then you're on a different level than me. How about another example that you might come up with by factoring, but probably not yet? X squared equals negative 4. Because if you try to solve this by factoring, you're going to add 4 to both sides. You're going to have x squared plus 4 equals 0. And you're going to say, well, that's prime. Because you can't factor a sum of squares using real numbers. Notice I said using real numbers. Yes, it's factorable with imaginary numbers. We'll get into that later. But for now, we're not. So what do? You take the plus or minus square root of both sides. Plus or minus only on the side with the number. Square roots and squares cancel, so you get x on the left. That's a plus or minus. The square root of negative 4 is not 2, not negative 2. It's 2i. And we're done in one step. So this is a really strong technique, but it's very specific. You have to have just something squared on one side and just a number on the other side. Now, this plus or minus square root issue is going to continue to be seen throughout problems, even if you don't use the square root property. It's embedded in the quadratic formula, which we're not even gonna do yet. Wait a second. What? I think I goofed up something. Hold on. Let me give me 10 seconds. Actually, I didn't. I just have something written twice. That's all. Okay. So now we're ready to introduce the second method of solving any quadratic, because these were special quadratics. These didn't have a regular old x term. They always had an x squared in them, and just the x squared in the format seen. So the second method we want to do is completing the square, and it's a big old list of instructions. Give you several minutes to write this out while I talk about it. Completing the square on something that looks like ax squared plus bx plus c. And let me put this equals 0 in here. I don't know why that wasn't there. Now, this method does work if the equals 0 isn't there, but it changes one or two of the steps a little bit. So we're dealing with completing the square in an equation. This doesn't have to be used in equations, but it changes things a little. We're not going to worry about that for now. You can also complete the square inside of parentheses, which changes the game a little too, but again, let's not worry about it. So completing the squares for our general quadratic, ax squared plus bx plus c. Now this is the odd one out. This is the odd person out, because with factoring, we want everything on both sides. I'm sorry, we want everything on one side. With the quadratic formula, we want everything on one side, but with completing the square, we actually want the constant on the opposite side of the variables. We want all the x's on one side and all the constants on the other. So this is a little different. In fact, all of this is a little different. This is a very much a do this, do that, do this, do that to make some mathemagics happen. And it seems like, well, how in the what kind of rabbit are you pulling out of the hat, Mr. Beckner? But it always works. And we can kind of discuss why it works. But it's a little bit of a trust game here. Move the constant to the other side. So in other words, this little plus c, if that was a plus 5, I would subtract 5 on both sides. Excuse me. Then, if the leading coefficient is not a 1, divide all terms by it. This is very critical for the method. If this is a 2x squared or a 4x squared or a 9x squared, that can't be to continue, so we have to divide it out. So if this is a 2, you divide every single bit you see by 2. If it's a 9, you divide every single bit you see by 9. If it's a 5, you divide every single bit you see by 5 in order to make it 1. And we're not breaking any rules of algebra. Whatever you do to one side, you do to the other. We're just making it convenient for us. We're trying to make something magical out. Then, step 3. We're going to have some side work, kind of like when I was taking the constant and splitting it up. We're going to have some side work. And the side work is very explicit. You take half of the b. At this point, whatever number is in front of the x, that's what I mean by b. Not necessarily the original number if it was divided out. It's whatever you see in front of the x now. So you take half of the number in front of the x, write that down, including its sign, because that's important. Write it down, then take that value and square it and write it down. So in other words, at this point, if this was a 6x, a positive 6x, you take half of it, which would be a plus 3. Write that plus 3 down. Then you square it. Positive 3 squared is 9. You write that down. Both the plus 3 and the plus 9 are important values. Half it, square it. Half it, square it. Half it, square it. Half it, square it. This is to set up something known as a perfect square trinomial. It's a factoring formula that I don't actually cover in here officially. You can find it in the 1.5 material. You can find it online. And the reason I don't cover it is because you can just factor by the other two methods. It's an alternative extra method that we don't have time to cover. But it's like if you had a x squared plus 6x plus 9, it factors to x plus 3 squared, because both of the factor pairs end up being the same, plus 3 plus 3. Or if you had x squared plus 10x plus 25, it would be x plus 5 all squared. And that's because of if you took the middle number, halved it, and squared it, you'd get the end number. It's a very, very, very special case. Well, what we're going to do is we're going to create that special case by taking the terms with the x's, taking the number in front of the x, halving it and squaring it. You will be guaranteed to get a perfect square trinomial on the left-hand side. LHS means left-hand side. RHS, right-hand side. And the factored form would be x, then plus or minus whatever the sign of that halved number was. B over 2, this is the halved number. That's what I'm saying by B over 2. And then a square. At this point, you will have an anything squared equal to a number, and you use your square root property. You take a plus or minus, square root both sides, and you're pretty much done at that point. This is a very specific recipe. This is a recipe a lot of students don't like because they need to practice it a dozen times before they get it down. It's very leap of faith heavy. You're walking off the cliff with me. But trust me, it works 100% of the time. And I said only 2% of problems in the world can be factored. 100% of the problems in the world can be solved by completing the square. You know what happens when you learn how to bake a cake and then your instructor says, all right, now take away the recipe and do it. How do you get to the point where you can take away the recipe and do it? You do it over and over and over and over and over. Practice makes perfect. You know what happens when you learn the cello? You know, initially they give you the fret markers so you can see where your notes are and your different positions and all that stuff. And then when you go and do your recitals, they take away your fret markers. You have to eventually learn where those positions are. How do you do that? Doing it over and over and over and over and over. Muscle memory for the cello. Here it's brain memory, which sounds redundant. Move the constant to one side. Variables on one side, constant on the other. Make sure the leading coefficient's a 1, so divide out whatever the leading coefficient is. Then take whatever the number with the x is, half it and square it, both those numbers being important. The squared number is what you add to both sides to make your perfect square trinomial. And then you don't even have to think about what the factored form is. It is automatic. Sure, you can factor it manually if you like, but there's going to be times where you're not going to know how to factor it because you're going to see fractions. And that sucks if you see fractions. Well, if you see fractions, it won't matter. It's an automatic form. It's just x and then the number that was halved with its appropriate plus or minus. Then it's a plus or minus square root of both sides, and you're pretty much on the way home. Now, I'm not going to throw you to the wolves immediately. I'm not going to start with examples where we solve by completing the square. I just want to take a couple examples where we practice the halving and squaring element of this. So we're going to do a couple examples where all we do is focus on steps 3 and 4. Okay? So for example 3, find out what you would add to both sides by completing the square on these terms. So let's say you had x squared plus 12x. I'm going to erase this blue ink in just a second. Let's say this was equal to 3. What I'm saying is ignore the equals 3 aspect. We're just focusing on this and figuring out what we would half and square, what we would add to both sides to fix this problem and make it factorable. So this is just the left-hand side of the equation. This is what we have at the end of step 2. So I'm saying we're looking at something at the end of step 2. The black ink that we see on the screen is what the left-hand side would have been. So our side work, we're just focusing on these 2 steps once again. Take half of the number paired with the x, that's what b means, and then square it. So to this side, I'm taking the positive 12 and I'm halving it. Why halving? Because that's how that formula works to set up a perfect square trinomial. Well, half of 12 is 2, so that's a positive 6. Notice I still write the positive. I could have read the positive for the 12 as well. Then we take this value, this positive 6, and we square it, which would be 36. Now, when you square a number, no matter what, it's positive unless you add an I, which you won't. So I'm not going to write the positive because that's what you're always going to add to both sides. Now, the 6, this is the halved number, which I'm going to write as the factor number, F for factor. That'll come into play later. The 36 is what we would add to both sides. So we would add 36 to both sides. That is what would create a perfect square trinomial. And x squared plus 12x plus 36 is definitely factorable. It would factor into x plus 6 times x plus 6. But because those factors are the same, you could write it as x plus 6 squared. And look at this. That factor number is the same thing as what you see inside the parentheses here. So the red ink is what I'm telling you that you'll be able to skip ultimately as long as you memorize this process. Do you have to skip it? No. But sometimes that red ink will have fractions in there and you're not going to know how to factor it, and then you're going to be out of luck. One more. X squared minus 7x, and everything I just said relates to this one. So x squared minus 7x. So again, the main point of this example is just to find out what we would add to both sides if this was written as an equation. So the side work, what do? We take the minus 7, the thing paired with the x, and we half it. Well, half of negative 7 halves is, well, negative 7 halves. Then what we do is we take this value and we square it. And because it's a fraction, because it's a because it's a negative, you'll need a parentheses there. Square top and bottom independently. 7 squared is 49. Negative squared is positive. 2 squared is 4. And that's what we would add to both sides. This is what we would add to both sides. The negative 7 halves is what I call the factor number. So our parentheses squared would have the negative 7 halves in it. So here we would add 49 fourths to both sides. Now again, what I'm ultimately really saying here is that x squared minus 7x plus 49 over 4, I have absolutely no idea how to manually factor this red ink. Actually, I do, but you probably don't. It's a much more advanced technique. But you don't have to go through that process. It is automatically an x in a parentheses squared, and then the number that goes with it is just the negative 7 halves. It's an automatic factoring form. That is a beautiful, beautiful feature. So again, all we really worked on there in example 3 were steps 3 and 4 of completing the square. I did also in red show you how 5 and 6 work. Well, I'm sorry, just step 5. But that wasn't the point of the problem. All right. And I had confused myself earlier. I was like, why do I have this written twice? And now I remember, because that's getting the instructions are going to be off screen, but I still want them seen here. For example 4, solve by completing the square. You do not need to rewrite this. This is the exact same instructions as before. I just copy pasted them so they're still on screen for you. So for example 4, solve by CTS. Math teachers love abbreviations, which means complete the square. For A, we're going to have x squared minus 8x plus 3 equals 0. Now you might say, oh, I hate this method. Why is Mr. Beckner making me do this? I'm going to solve it by factoring. No, you're not. No, you're not. This problem's prime. Can't solve it by factoring. It's a 98%er. And that statistic is made up, by the way. It's probably actually like 99.9% in all honesty. But the point is still valid. If I just make 3 random numbers up there, it probably isn't factorable. All right, deep breath. Who's Shraba? Let's try this out. Now, what you also might say before we try this out is, I'm just going to do the quadratic formula. Well, you better be careful. If I check your work and I find out that you didn't follow instructions for this type of problem, I might take a point or 2 off, even if you're right. Now, ultimately, does it actually matter? No, but this technique is important for other aspects of calculus that will be important later. So in pre-calculus, can you get away without completing the square technique? Pretty much. There's exceptions to every rule. But at the end of your math careers, it's going to be necessary at some point. So don't dust it under the rug yet. All right. Move the constant to the opposite side. So I need to subtract 3 on both sides. This feels weird. No other technique does this. That's okay. Just because something's weird doesn't mean it's bad. Story of my life. I'm weird, but I'm not bad. X squared minus 8x equals -3. Now what we do is that side work. What about step 2, Mr. Beckner? That says if the leading coefficient isn't a 1, there's no number written here, which means it's a 1. So we can skip step 2. Hallelujah. Praise the math gods. So we go and do our side work. To the side, take half of the x value and then square it. Now, both of those numbers are important. So what's the x value? That's the -8, the x coefficient. So we half that, which is -4. Then we take the -4 and we square it, which is +16. That's what we'll add to both sides. The -4 is what I call the factor number. Now we're at step 4. Add the squared value to both sides. So we have our x squared minus our 8x. I'm gonna leave a little space, and then our -3, just so I can change colors. We add 16 to both sides. This will never, ever, 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 ever be a subtraction on both sides. It's always add. An alternative phrasing for this is to add and subtract 16 to the left side and then move the -16 to the right side, but that's just beautiful. So have I changed anything? No, I have not changed anything mathematically. I just made the left-hand side more convenient. I have done this so that the left-hand side is now a perfect square trinomial. I have created something convenient that was not written before. So no matter what, that left-hand side is always a parentheses squared with an x in the first spot, and then either a plus or a minus, not both. That's why I wrote the word or there, so you don't confuse it with the plus or minus symbol. And then the factor number. It's this number right here, because that's a -4. That's what goes here. Now, most of you, all of you should have been able to factor x squared minus 8x plus 16 pretty easily and ultimately end up with x minus 4, but it's a shortcut. And again, there are times when it's not easily factorable, like fractions are involved or uglier numbers are involved, and then it's a major, major shortcut and headache saver. The right-hand side is, well, negative 3 plus 16. It's whatever it happens to be, 13 in this instance. Alrighty, so what do we do from here? We apply the square root property. In other words, take the plus or minus of both sides, plus or minus square root of both sides. So we get the square root of x minus 4 in parentheses squared. I was supposed to be black. And then the plus or minus square root of 13. So our square roots and squares on the left-hand side will cancel. We get x minus 4. Much simpler looking. The right-hand side, we don't know the square root of 13. We can't simplify it. Leave it alone. Now, even though that's some ugly number, we're focused on the x minus 4 side. We're just focusing on this. We got to get rid of the minus 4, though. We just add 4 to both sides. But we make sure it goes in front of the plus or minus. Otherwise, it means something completely different. We get x equals 4 plus or minus the square root of 13. And that is our solution that you would have never found by factoring, unless you know stuff I don't know. In which case, cool. The interesting thing is knowing the solution, you can write a factored form, but you can't find the solution by factoring. It's a implicit process. It's backwards. It's like playing Jeopardy. We'll talk about that in chapter 3. Muhahaha. Let's try another one of these. X squared plus 6x plus 11 equals 0. And I wanted to write take there. All right. So first thing we need to do is move the 11. So we get x squared plus 6x equals negative 11. Also, this problem was prime, just so you know. Then what do we do? If the leading coefficient's not a 1, well, it's a 1, so this is fine. Honestly, if it wasn't a 1, I would probably just use the quadratic formula if I had a choice. But you don't always have that choice. So we're at step 3. To the side, take half of the b coefficient, the x coefficient, which I'm calling b, and then square it, write both of those down. So we had a positive 6. Half of that, and you get positive 3. Square 3, and you get 9. That's what we add to both sides. The plus 3 is what we have written in the factored form. We have our x squared plus our 6x. We have our equals negative 11, but we're going to add 9 to both sides because that's what the squared number was. We do that for convenience because step 4, once we add that squared value to both sides, step 5 is automatically of the form x something squared, and then the number with the sign that goes here was this. It's a plus 3. Equals negative 11 plus 9 happens to be negative 2. Whoop-de-doo. Then we take the plus or minus square root of both sides. Why? Because we have an anything squared equal to a number. This was not an anything squared. I couldn't take the plus or minus square root at that point because it wasn't just something all being squared. This is something all being squared. So square root, plus or minus square root. We don't know the square root of -2. We don't know the square root of 2, that is, but we do know the square root of negative. We pull out an I. Square root and square on the left side cancel. So we get x plus 3 equals plus or minus I square root of 2. You have to pull out the I or this is wrong. And you are going to be very frustrated if you get every aspect of this problem right in a homework problem and forget to pull out your I. Again, test, show your work, you get lots of partial credit, you point it out. But homework is the trenches. Subtract 3 on both sides to isolate your x. Again, it didn't matter how ugly that plus or minus value was. We get x equals -3 plus or minus I square root of 2. And we're done. Imagine getting that answer by factoring. Oh, Lord. Again, it's a very specific list of instructions. And you might hate it after only doing 1 or 2. Do 10 or 20, you might feel different. Nobody likes how a cello sounds after you've practiced once or twice on it. After you practice 10 or 20 or 50 times, you start getting proper notes out of it. You got to build up those calluses on your fingers. You got to learn where the notes are. You got to learn how to hold the bow and how to drag it across the strings. And I say this not as a cello player. I just know some stuff. I know how it works. Can't make it work properly. Now, I'm going to show a C. I forgot I actually have this written up here. 2x squared minus 20x minus 5 equals 0. But I'm not going to show all the work for this. I'm going to show you how you would start this. I'm going to show you what the answer is, but I'm going to let you try and finish this on your own. Quite honestly, I would never on a test tell you to solve this by completing the square. I would either give you a choice or tell you to do the quadratic formula. And I'll explain why that is. Because I would never personally do this by completing the square. First of all, I don't like completing the square when the leading coefficient is a 1, especially when, second of all, when I go to clean that up, I'm going to introduce fractions. Basically, if I see an odd number somewhere besides the leading coefficient, when the leading coefficient is a 1, I would never complete the square because it's ugly. I would do this with the formula. All right, so what's the process? You move your 5 to both sides. Move your 5 by adding it to both sides, excuse me, which would give us 2x squared minus 20x equals 5. Well, unfortunately, for the first time, the leading coefficient isn't a 1, so we need to fix that. That's that step 2 we haven't seen yet. So we divide everything by the 2. This is us dividing both sides by 2, which gives us x squared minus 10x equals 5 halves. This is what I don't like. Or in the next step, if I introduced a fraction. If you see a fraction somewhere with completing the square, stop, switch methods. Switch to the quadratic formula because this is just going to suck. Okay? So this is where I would say, nah, dog, I'm not doing it this way. I'm going to do the quadratic formula even if you told me to complete the square. So here's what you would do to finish this problem, to start finishing it at least, if you were going to continue. So then to the side, we take the -10 and we half it, which would be -5. We take our -5, we square it, which is positive 25. That's what we add to both sides. This would be our factor number. So what we would get here is x squared minus 10x. Then we would add 25 to both sides. We still have the equals and the 5 halves. The left-hand side becomes x minus 5 squared. The right-hand side is, well, whatever number 5 halves plus 25 is, you're going to have to get an LCD and combine them. Then you're going to have to take the square root of that, which you're going to have to clean up a square root of a bottom. It just gets really, really ugly. And the solution ends up being 5 plus or minus the square root of 110 over 2. So if you can finish that on your own, you're doing really awesome. But again, it is at this point, the second I saw a fraction anywhere in this problem, I would have hit the brakes and I would have said, nah, let's do quadratic formula. So again, I'm not going to tell you on a test to do a problem by completing the square if there's a fraction. And if I do, just go ahead and do the quadratic formula anyways. I wouldn't discount you. That's the one time where I wouldn't say, well, you didn't use my method, so I'm taking a point off. I wouldn't do that. So completing the square always works, but sometimes it will give you a headache. When does it give you a headache? When fractions start getting involved. That was just all the same stuff. Right. Oh, I thought I might not have that written out. The final method. And no, I'm not going to sing the final countdown. For a, x squared plus bx plus c equals 0. So if you took this ax squared plus bx plus c equals 0 and you applied completing the square, if you subtracted c on both sides, and then you divided both sides by a, and then you took half of b divided by a and squared it, and you added that to both sides, and then you wrote your automatic factored form, and then you moved a term over after taking a plus or minus square root. And all with a's, b's, and c's instead of numbers, which just makes it look like a headache. You know what you get? You get the quadratic formula. Solutions to this are always x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. If you do not memorize this, we're going to have some beef. Let's go ahead and squash that beef now. It's never going away. You go into calculus, it's never going away. You're going to finish this course with me, it's never going away. If you don't memorize this, you will lose lots of points in lots of places. However your brain works to memorize something, get on it. Write it 50 times, say it 50 times, use it 50 times, read it 50 times, have someone else read it to you 50 times. There are lots of little features that you can goof up. Maybe you forget the negative in the first part. Maybe you forget the 2 in the bottom. Maybe you swap the negative b and the b squared. Maybe you take that division and don't drag it all the way across. Maybe it's just under the square root. Maybe you forget the plus or minus. A lot of students will say there's a little song that goes with this. I'm not going to sing to anybody. I don't have a singing voice. You can Google it. I'm sure you'll find a little melody to it. What are we up to? Example 5? Yes. So example 5. Solve. Quadratic formula. And for A, this problem is going to feel familiar. It's going to be x squared plus 6x plus 11 equals 0. X squared plus 6x plus 11 equals 0. That sounds familiar. What sounds familiar? Because we just did that in example B. X squared plus 6x plus 11 equals 0. Do you know why I'm doing that? Because you already know the answer. You'll have something to compare to in case you either don't trust completing the square, but you do the quadratic formula. And when you see they're the same, you go, oh, it worked, or vice versa. So we know what the answer should be. And you know, if it was a test, maybe you can be slick and, oh, it's the same thing. Let me just type it in and get it right. Well, if it's a handwritten test, that would be a bigger problem, which we will be doing since we're going to do in class. But if we end up going back to Zoom, it's another case. But I could still say, well, I'm going to go back and look for your work. And if I don't see the work and you didn't follow the instructions, you're not getting full credit. All right, so here's what you should do. You got to make sure everything's on one side. This is not move the constant to the other side and all that jazz. Everything needs to be on one side, just like if you were going to factor it. So this is actually set up for success. If the 11 was on the right side, you'd have to move it. If the x's were on opposite sides, you'd have to move something. So here's what I like to do. I like to write what my A, B, and C are. They're all positive, so it's a positive 1, positive 6, and a positive 11. If any of them were negative, make sure to write the signs. And then all we do is just jam these three numbers into the formula. This is called a plug and play problem. It's cruise control as long as your arithmetic skills are on point. If you don't know how to simplify square roots, you're going to have a problem. If you don't memorize the formula, you're going to have a problem. So x equals negative b. Watch out when b is negative, because then you're going to have a double negative situation. Plus or minus square root of b squared. So that's 6 squared. If that was negative, you'd need a parentheses. Minus 4 times a, which was 1, times c, which is 11. B squared minus 4ac, all under a square root. Then this is all divided by, make sure it goes all the way across, 2 times a, which is 2 times 1. From here, it's just arithmetic. PEMDAS, baby. 6 squared is 36. That's negative 6 plus or minus the square root of 36. You can take more steps to simplify this. If you want to wait to do your multiplications, be my guest. But because of the plus and minus, this particular minus, I can go ahead and say 4 times 1 times 11 is 44. So that's a minus 44. It's a negative times a positive times a positive. All divided by 2 times 1 is 2. Well, 36 minus 44 is negative 8. So that's negative 6 plus or minus the square root of negative 8, all divided by 2. Now, I don't know the square root of negative 8 directly, but we can simplify it. We talked about earlier how the square root of 8 we could write as 4 times 2. There's a negative in there, so that's the square root of negative 4 times 2. Square root of negative 4 is not just 2, it's 2i. And then we still have that 2 on the inside. Again, the square root of the negative 4 is where this 2i came from. So what we now have is x equals negative 6 plus or minus 2i square root of 2 all over 2. And if you stop here, you're not done. Because all of the outer values in this fraction are divisible by 2, so this is reducible. So I'm just rewriting it, but I'm going to show the reduction. 2 divided by 6 is, 6 divided by 2 is 3. 2 divided by 2 is 1. 2 divided by 2 is 1. So this is negative 3 plus or minus I square root of 2 over 1, which you don't need to write the over 1. You get negative 3 plus or minus I squared root of 2, which is exactly the same answer we got last time. It worked. How about that? All right. I do not think we have enough time to justify doing B, so we're going to go ahead and call it there. So when we come back next class in person, we will cover B and C, and then we'll go into that thing you might have seen on the screen for a second called the discriminant, and that will close out this section. So we got about 15, 20 minutes left, which is exactly where I wanted to finish. So although I'm not going to say this homework section is due in a week, I do highly suggest that you go ahead and start it because it's a pretty beefy section. go ahead and start what you know you can do. We went over the solve by factoring. We went over solve by completing the square. We went over the square root property stuff. So maybe just wait on the quadratic formula stuff. However, you might already have enough practice with this to solve that as well, and then you're just ahead of the game. So again, technically no new homework due dates, just the 1.4, which we said was going to be due February 1st, right? Yeah, February 1st. All right, so if you have any questions, as always, you can email me. Remember that we will be meeting in person. I don't have the classroom off the top of my head, unfortunately, so check SIS to make sure you go to the right classroom. It's in the A building. It's probably A105 or A109 or A217. It's going to be one of those three, but again, double check to make sure you end up in the right place. And yeah, so we'll see you on Tuesday morning in person. It's going to be awesome. I look forward to seeing y'all. I look forward to meeting y'all officially finally. Have a good day. Have a good weekend. Take care.